Okay, so for the prime factorization practice page, I'm going to work out a couple of them just to demonstrate how to solve these. So for number one, and I apologize, it's a little difficult for me to write on this screen with my mouse, so it won't be the neatest, but hopefully I still get the point across. So it's 18 and 20. So 18 and 20 are what we need to find the greatest common factor for. So I'll list these out here. So it is asking you to find them using prime factorization. To find the prime factorization, I like to use the factor tree technique. So I'm going to do 18 first. Change my color to work that out down here. So for 18, I start making my factor tree with two factors that multiply together to get 18. So 9 and 2. 2 is already prime. Remember, prime is a number that is only divisible by 1 and itself. So I'm going to circle that. I've already got my prime factor there. 9 is not prime, so I factor it out into 3 times 3. So remember, and if you line these up in the rows should always multiply to get the number above it. So 9 times 2 is 18. 3 times 3 is 9. 3 is prime, so I'm going to circle those. So my prime factorization for 18, I always start with my smallest number. 2 times 3 times 3. Now to do 20. Pick a different color to do that one. Okay, 20. I'm going to do 2 times 10. You could do 4 times 5. It doesn't matter which factors you pick. As you work out the factor tree, you will always get the same prime factorization. So 2 is prime, 10 is not. Go to 5 and 2. Those are both prime. So again, I'm going to put them from least to greatest order. So 2 times 2 times 5. I can check to make sure that I am correct by multiplying my prime factors, and I should equal my main number. So 2 times 3 is 6, times 3 is 18. I'm correct there. 2 times 2 is 4, times 5 is 20. So there's my prime factors. Now it wants you to find the greatest common factor by selecting the prime factors that are shared by both numbers. So for this one, I'm just going to put a box around them. 2 and 2, but all I have left here are 3s. I don't have any 3s down here. So the only common prime factor is 2. Now I take all of my common prime factors and I multiply them together. All I have for this one is 2. So my greatest common factor, GCF, for this one would equal 2. Okay, that's number 1 worked out. I'm going to do one other one here. Let's do number 5. Number 5. So I have 30. Oops, sorry about that. I have 30 and 15. Okay, I'm going to factor those using a factor tree. So 30, let's say 3 times 10. 3 is prime. Going to factor 10, 2, and 5, and those are both prime. So my prime factorization for 30 is 2 times 3 times 5. Again, I can double check that. 2 times 3 is 6, times 5 is 30. So that one is correct. Make sure that all the numbers we have here are prime, which they are. For 15, break that apart into 3 and 5. Both of those are prime, so I've already found my prime factorization. Going to put those in order. 3 times 5 equals 15, and that is correct. Now I see if there's any in common. So I'm going to put a circle around these because there's a 3 and a 3. And a circle around these because there's a 5 and a 5. Now I take those common prime factors and I multiply them together. So 3 times 5, and that is going to give me my greatest common factor, which is 15. So my GCF, greatest common factor, for 30 and 15 is 15.